Well, marine heat waves can occur on relatively small scales. Okay, say of a few kilometers, can be in rivers, can be in lakes, can be in coastal oceans. Let's talk about the biggest events. Okay, let's talk about events on a scale of several thousand kilometers. Heat waves on large scale associated with ENSO, the El Nino Southern Oscillation. Okay? And these are events that impact coral reefs, which are located in the warm water regions on Earth, in the warm water pool. So we're talking about the areas which are very warm, which hold the warmest water above 25 degrees Celsius, often above 30 degrees Celsius. This is what we call the warm pool. Here you can see here is the average sea surface temperature on Earth, and you can see the warm pool. It's the area in the West Pacific and in the northeastern Indian Ocean, which has the warmest water. Okay? And variations caused by this in the sea surface temperature field. Okay, you can also see, we discussed that before, the impacts of coastal upwelling. On the eastern side of the Pacific Ocean, for example, here you can see a drop in the surface temperatures. Also north of the equator, that's the Californian upwelling system. Okay, just quickly a reminder of what we're talking about, and it's the ENSO is a coupled mode of climate variability. It includes the atmosphere and it includes the ocean. It's a coupled, and the coupling mechanism is provided through the sea surface temperature. The sea surface temperature modulates the evaporation. The evaporation, the transfer of water, vapor, water into the atmosphere, which indeed feeds into tropical convection. Okay, we talk about this is to do with the Walker circulation, and you already know all about it. Okay, so this is just a quick reminder. Okay, so your neighbor comes knocking. Hey, what's the Walker circulation? And here it is. Walker circulation is an atmospheric circulation which actually has the trade winds are the surface signature of the circulation. It blows along the tropics of the Pacific Ocean from east to west over several thousands of kilometers, and on the western side it triggers a intensified atmospheric convection and the formation of clouds and rainfall over the warm pool. Okay, it's the warm pool that stimulates the tropical convection in the western Pacific. Okay, in the atmosphere, in the ocean, the characteristics are that you have upwelling along the equator in the Pacific, so the temperature is a little bit lower along the equator, and on the eastern side you have the Peru-Chile upwelling systems. Okay, that is illustrated here in the sketch by a cool water signature on that side. You can see the thermocline is lifted, comes close to the surface here on the eastern side. Okay, and so now this coupled interaction between the atmosphere and the ocean triggers an oscillation. Okay? Oscillation is something that's at some time apart. It has a positive and a negative phase, and it swings from one phase into the opposite phase. Again, the opposite phases are shown in this diagram, okay, where you have in the top level, you can see sort of more the normal situation. Okay, you have tropical convection rainfall in the western Pacific, upwelling in the eastern part of the ocean, and then during El Nino events, there is a variation to the warm pool actually moves over to the central part of the Pacific. Upwelling in the eastern side is suppressed, okay, and so you have a change of the sea surface temperature field. So this is what we're talking about. Marine heat wave associated with change in the sea surface temperature. So let's have a look. How does it look like now during El Nino event? Where does the temperature actually change? Okay, I discussed this before, but let's just look at the areas where you have change. So here is the famous 1997-1998 El Nino event, and let's just spend a little bit of time on it. Okay, so before this event, the sea surface temperature, the distribution looked like what's shown in the top left panel. Let's go there. And the colors mean red is above 30 degrees. Here the orange red, more than 30 degrees. And blue means 16 degrees or something, less than 20 degrees. Here on the east you can see that. So that's sort of the typical situation where you have a warm pool, okay, located in the western part, and you have the upwelling in the eastern part. You notice that the upwelling, the Peru-Chile upwelling system, is actually connected to the equator. You can see there is a connection here, and you can see also that at the equator you have lower temperatures. This is what we call the equatorial. Okay. So now what happens after the El Nino event? The temperature after the El Nino event is shown in the middle panel. You can see essentially the warm water pool now extends all over to the eastern part of it. Okay, you can see this red band all exceeds over. Now if you want to know where has the temperature changed, all you need to do is take the difference. Here, the difference between these two distributions is shown here at the bottom, and you can see now that there are changes of the biggest changes of more than 4 degrees are highlighted, essentially from about halfway cutting through the Pacific Ocean to the eastern part along the equator. You can see this big zone where the water is relatively warmer now, 4 degrees warmer than in the normal situation. But there are also many other areas hidden here where the temperature is 2 degrees warmer. Okay, all the yellow areas that you can see areas where, away from the equator, which are impacted. Okay? And how this happens is actually that the El Nino, you can imagine that it's like a wave. Okay, it's a disturbance, a wave that propagates around the equator in the atmosphere, and it creates a wind anomalies, and these wind anomalies trigger coastal downwelling, coastal upwelling, a movement of temperature anomalies, and so on. It's not only restricted to the equator. El Nino events have an effect that can spread much further into the ambient oceans, and I'll show you some examples. Okay, so let's have a closer look at